we talked about the incorporation of a gene. So this has to do with that question where you're trying to incorporate, you have this lab student that basically trying to incorporate a eukaryotic gene for insulin into a prokaryote because he wants to make insulin. And so he's thinking that you can go ahead and incorporate gDNA. You guys have to justify if he's correct or not correct in incorporating gDNA. Then you want to talk about what kind of enzymes do you need to cleave DNA and incorporate it into a plasmid. What enzyme do you need? They're a class of enzymes. Restriction enzymes, right? So there are endonucleases that are cutting inside DNA by recognizing restriction sites, which are palindromic. So if you read them 5' to 3' on the top strand, or 5' to 3' on the bottom strand, they read the same way. And would you prefer restriction enzymes that form sticky ends or blunt ends? And why? So do you guys remember what sticky ends are versus blunt ends?
Sticky ends and overhang.
So they have 3' overhang, right? Remember where the restriction enzyme. The restriction enzyme, when say this is double-stranded DNA, right? It can either end up doing this, or I can end up doing this.
It has a 3' overhang, but it has a 5' overhang on the other. No?
3', 5', 3'.
Oh, okay.
So these are what's called the blunt ends, right? So you would prefer sticky ends, so these are blunt, right? It's right here. And you prefer sticky ends because the idea is not only, yes, you can have DNA ligase glue them together and they'll be stable, but you also have additional support by hydrogen bonding that can happen between the overhangs. So if you use restriction enzyme to produce a 3' overhang, then these would be more stable than this. It's like a jigsaw puzzle, right? If you have a jigsaw puzzle, say the shape helps hold the pieces together, and then if you want to frame it, you can go ahead and frame it, and that the frame also helps keep it in place. It's also the shape, the way they interact, that's also helping them stick together. So you prefer sticky ends.
Why are there restriction enzymes that leave 5' overhangs instead of 3'? Are they always 3'?
I think it was 3'.
Just like that?
I don't know why. Is it because is this naming mechanism because of like the convention of DNA always being transcribed 5', 3'? But they're always saying that whichever site comes first. I don't know. I don't know if it's based off of convention or if it's based off of like it's always after the start. That it's always a template strand, the 3' of the template strand.
Which can't be convention. That's a real thing there. There's no other way to do it, right?
I'm not sure if they have 5'. It's always a 3. I'm not sure. Good question though.
And DNA ligase is going to be needed to seal that up, right?
Mm-hmm.
So can that work from 3' to 5', or does that?
What do you mean?
I guess it's just connecting to. It doesn't.
It's making the positive ester bond.
Right.
So it's going to basically connect the backbone again.
Yeah. So hypothetically, if the overhang were,
You're saying this part goes here? I don't know.
ignore me. thinking about like if the ligase could only work in one direction, but it doesn't matter, it's a single point. So it doesn't matter.
It's a single point thing. Where we have phosphorylation bonds in one single gum, where we have a ribose sugar, or deoxyribose in this case, deoxyribose and phosphorus. So it's number 3 real quick.